Hello 20-1 students. So today we're looking at solving irrational equations. Sorry, when I printed this out I accidentally did the wrong one, wrong word there, but I fixed it for the notes that are uploaded for you guys, so it should all be good in the notes that you'll have online. So with solving rational equations, basically what we're looking at is up until now, we've worked with rational expressions and we've learned what they are and then how to do different operations with them, like multiplying and dividing, adding and subtracting. And now what we're going to be looking at is when you have an equation that contains these rational expressions and you need to solve for the variable. Okay, so it's a little bit different. We're not just trying to do operations with the expressions. We're actually trying to bring it down to a point where we can solve for the numerical value of the variable. Okay, so basically that means that a big difference, a lot of working with rational equations is similar to working with rational expressions, but a big difference that we see happening is in the equation, because we're using algebra to rearrange and solve for the variable, we actually end up like having to do everything the same to both sides of the equation so that we can, solve for the variable and move things around to solve for the variable. Yeah, I think that's all I'll talk about for now, and then we'll see what comes up as we go through some examples. So we have an example of a solution to a rational equation here. And just to start out with, so we can kind of figure this out on our own, we want to figure out what is the process that is happening in here that ends up leading to the solution. So here we have our rational equation, and we're asked to solve it. And so in this first step here, we're asked what happens here. So if we look at what is the difference basically between these two, well, here we have 2 and 2, but down here z squared minus 4 is factored into z minus 2 times by z plus 2 because it's a perfect square. In this one we have 10 as the numerator, and then instead of 6z plus 12 here we have 6 times by z plus 2. So again we see factoring happening, and then with this one there's nothing that could be factored out, so we see that it remains the same. So our first step, just like we kind of got used to when we were solving rational expressions, is factoring. In step 2, now again this was a little bit of a typo because it was supposed to say z cannot equal plus or minus 2. So essentially what we're doing here then is if we're ever saying that a variable cannot equal something, we're looking for the, hopefully you guessed, NPV. Okay, so the non-permissible value. So the nice thing with solving rational equations is that because we don't continue to change around the denominator as we move forward, we're actually trying to cancel it out, which we'll see later on. You can very easily identify the non-permissible value as soon as you've done your factoring. Then in this step we see, so here in these square brackets we have the expression that we had in this step, and in this one we have the expression from up here, but we see that both sides are being multiplied by z minus 2, z plus 2, 6. So if we look at what's up here, what does that mean? Well, we can see that in this denominator we have z minus 2 and z plus 2. Z plus 2 is repeated here and z minus 2 is repeated here. So the only new denominator that we see in all of these after the first one is the 6. And so that's what we see represented here is our lowest common denominator for all three expressions. Now what we actually want to do here is, you can see that they're multiplying it through by each of these expressions, including the one on the opposite side of the equal sign. And basically what that's going to mean is if you multiply all of these terms, so the entire lowest common denominator by the top, like by the numerator here for example, multiplying this by this by this by that is what we'll end up with, and then divided by this. So when that happens, the z minus 2 on the top is going to cancel out the z minus 2 on the bottom. The z plus 2 on the top is going to cancel the z plus 2 on the bottom. And so you can see here in the next step we're not going to have the denominator there anymore. Same thing over here, we had 10 over 6 times by z plus 2. So if we multiply the 10 by all of these three things, again the z plus 2 and z plus 2 will cancel out, and the 6 and the 6 will cancel out. So we'll be left with 10 times by z minus 2. Okay, and you can actually see that's what gets carried down into the next step. And same thing here, we said that the z plus 2 and z minus 2 would cancel out, so the only other component that would stay would be the 6, and we actually see that that's what happened here in this step. Then over here, same thing, right? Z minus 2, Z plus 2 times by 6, we multiply that by 1. So basically we just end up with this on top. The Z minus 2 and Z minus 2 will cancel out. So as the numerator, we'll just have left Z plus 2 times 6. The denominator has canceled out, so that actually just becomes our full expression. So that's why we see Z plus 2 times 6 here. So what would we say is actually happening in this step? We are determining the lowest common denominator, so they found this value, and multiplying it through by all of the expressions. Okay, so on the filled in notes that you guys can find on the website, I've written that out, but I won't waste your time with it here. So then in the next step, you can probably guess, we've gone through and we've started to simplify, right? So we multiplied these out and we've canceled out things that were the same on the top and bottom. So the whole point of that was so that we wouldn't have any more fractions, because otherwise it's really hard to isolate variables. So now we're left with our simplified expressions. And what are we doing as we move further down? We see that this becomes simpler and simpler. So basically what's happening is we're just like doing the operations and simplifying. So 6 times 2 is 12. 10 times by z is 10z. 10 times negative 2 is negative 20. 6 times by z is 6z. And 6 times by 2 is 12. And then now after that, you want to combine like terms, right? So 12 minus 20. Oh, actually, it looks like they moved the number values to the other side in one step. So basically, if you had 12 here, you want to move the 20 over. So you're going to do plus 20. And then you have a positive 12 here, so minus 12. So basically, 12 minus 12 is 0, plus 20 is 20. And then on this side, we have positive 10z. We want to move the 6z over, and because it's positive, we subtract. So 10z minus 6z gives us the 4z. Then in order to solve for z now that we have it simplified, we just need to divide the 4 out of both sides, and that leaves us with z is equal to 5. Okay, so step 4, again, check the filled in notes, but basically you are simplifying and combining like terms to solve for the variable. Then in our last step, what's going on here? We have no variables, but you can see that there are, sorry, I should have done this before I recorded, but because that looks confusing, it looks like it's part of the step. But basically, you can see that we have expressions here that look similar to how we started out, right? So we started out with 2 divided by z squared minus 4 plus 10 over 6z plus 12 equals 1 over z minus 2. And down here, we've put in our z value is 5. So where we had z up here, we've substituted 5 in. Where we had z there, we substituted 5 in, and z there, we substituted the 5 in. So basically what we're doing in this step is we're substituting in the value we solved for the variable to see if it's accurate, because if this value is correct for z, then these two expressions combined should be equal to this expression. So again, just working through and simplifying, 5 squared is 25 minus 4 is 21. 6 times 5 is 30 plus 12 is 42, and 5 minus 2 is 3, so we have a third. Then, in order to add the fractions together, they've made common denominators. So basically, they've reduced this to a term like to a fraction that has a common denominator. So dividing both of these by 2 gives us 10 divided by 2 is 5, and 42 divided by 2 is 21. So it's an equivalent fraction, but now it's in a form where we can add it together. 2 plus 5 is 7 over 21 equals 1/3. And now again, we can reduce this to lowest terms. 7 goes into 7 once and into 21 3 times. And it is true that 1/3 equals 1/3. Oops. So that means we know that this value for z is correct. Okay, so those are the basic steps we use when we're solving rational equations. So let's try an example ourselves. Okay, so all the steps that we just looked at are written down up here, but we're just going to jump right into it because we kind of already went over those. So we want to solve this equation and identify the non-permissible values. So the first step, like we said, is to factor. So if we're factoring this, x plus 2 can't be factored, so we can leave it as 3 over x plus 2 minus, and then again, x minus 2 can't be factored, so we can leave it like that, equals, now x squared minus 4 is a perfect square, so it would be x plus 2, x minus 2, is how we would factor that. And so then we have 2. And then our next step is to identify the non-permissible values. So NPVs are x cannot equal, looking at what we have factored here, -2, +2, -2, +2. So basically x cannot equal plus or minus 2. Okay, so that's one kind of part of the solution there. Then our third step is to find the lowest common denominator and multiply everything through by it. So between all of these, we have x plus 2 and x minus 2, and then in this one we have both of those. So basically we just want to have both of those in our lowest common denominator. It's going to be x plus 2, x minus 2. And so we want to multiply that through by all of the terms in our equation. So I'm just going to actually multiply, actually I'll do it different. Okay, so 3x plus 2, x minus 2, right? So we're multiplying the lowest common denominator through the numerator for the first one, and we have x plus 2 on the bottom. So don't get this confused with when we're trying to add and we are trying to make the common denominator the same. In this case, we're multiplying the numerator by the lowest common denominator in order to actually eliminate the fraction. Then we're subtracting off, so 5x plus 2, x minus 2, and then dividing it out by x minus 2. And that should all be equal to, this one, if we multiply, we have 2x plus 2, x minus 2. And it's over x plus 2, x minus 2. So now looking at what is going to cancel out here. So we have x plus 2 and x plus 2 cancel here. X minus 2 and x minus 2 cancel here. And both terms actually cancel out for that one. So step 4, remember, is after we've determined our lowest common denominator, we want to start simplifying so that we can solve for the variable. So in this one, we would have 3 times by x minus 2. Our denominator is canceled, minus 5 times by x plus 2 equals 2, right? Because everything got canceled there. Now multiply everything through because we want to simplify. So 3x. 3 times -2 is 6, minus 5 times x. 5 times 2 is plus 10. Personally, I like to kind of keep these two components separated so that I remember that the subtraction has to apply to both of the terms in the second bracket is equal to 2. Now I want to combine my like terms. So this is what I meant with the brackets. So it's going to be 3x minus positive 5. So basically 3 minus 5 gives us -2x. And then negative 6, and this is where I think sometimes you can make a mistake, which is why I like the brackets, because I think a lot of students would say negative 6 plus 10, but it's not. It's negative 6 minus positive 10, and so that is going to give us negative 16, so minus 16 is equal to 2. Now we can start to work on isolating x. So I'm going to move across this way so I don't run out of space. We want to add 16 to both sides to remove it. So that's going to give us negative 2x minus 16 plus 16 cancels out. So that's going to be equal to 18. Then again, to isolate the x, we want to divide out the negative 2. And so that's going to give us, actually, sorry, the equal sign could be confusing there. So let's do negative 2 divided by 2 leaves us with x. 18 divided by negative 2 gives us negative 9. So now we've solved for our variable. The last step that we have to do is substitute and verify. So going back to our original expressions there, we had 3 over x plus 2, so we said x is negative 9 plus 2, minus 5 over x minus 2, so negative 9 minus 2, and that is equal to 2 divided by x squared, so negative 9 squared, minus 4. Again, we can move across, so negative 9 plus 2 is negative 7, so we have 3 over negative 7, minus 5 over negative 9 minus 2 is negative 11. So negative 11 is equal to negative 9 squared is 81, minus 4 is 77. So that's 2 over 77. So now in order to combine these two fractions, we would want to make sure they have a common denominator with all three actually, so that we can compare the two sides. So if this side is 77, you can see that this one would be pretty easy to solve for. We're just going to make these both into 77. So basically that means we need to multiply this one by negative 11. So negative 11 over negative 11 times by 3 over negative 7, oops, minus, and then for this one to make negative 11 into 77, we need to multiply it by negative 7 over negative 7 times by 5 over negative 11 equals 2 over 77. So this is going to give us negative 33 over 77 minus negative 35 over 77 equals 2 over 77. I'm going to bracket that because we have minus negative. Let's see, negative 33 minus negative 35 is basically negative 33 plus 35, so that gives us 2 out of 77, which of course is equal to 2 out of 77 on the opposite side there. So again, we've proven that our two values are equal when we substitute in the value we solved for x. So our verification is correct, and we know that we solved the equation properly. Okay, last question I believe for this section is solving an equation that has something a little bit different in it. So don't leave the lesson if you feel like you understand it all, because we're going to be looking at a little bit of a different scenario in this one, even though it looks quite similar. Okay, so again, first step is just factoring. We can see that these two aren't going to factor. X squared minus x minus 6 we will be able to factor. So let's break that down. 3x over x plus 2 minus x minus 3 with 5 over top. And that's going to be equal to, so if we were to factor this, we need two numbers that multiply to negative 6 and add to negative 1. So that would be -3 and +2. A lot of times with ones like this, you can also look, like if you're not sure, because usually they'll match up with other factored terms here in order to keep the lowest common denominator not too complex. So basically we're going to have x minus 3. I mean, still make sure that you factor it properly, but you can always use this as a little bit of a check if you're close to it, but maybe you have the positives and negatives switched. Maybe reevaluate how you factored that. So -25. Our second step is to find our NPVs. And so for this one, that would be x cannot equal. Basically, we just have +3 and -2, and it's the same over here. So -2 and +3 are our NPVs. The next step is going to be factoring. So, oh, sorry, not factoring, lowest common denominator. So LCD is x plus 2, x minus 3, right? Because that is present in all of our denominators. So we want to go ahead and multiply that through by all of our terms. So we're going to have 3x times by x plus 2, x minus 3, and then divide by x plus 2, minus 5, x plus 2, x minus 3, divided by x minus 3, equal to -25. Oh, actually I shouldn't push that over too far. I forgot I have to do my multiplying. So -25, sorry. X plus 2, x minus 3, x minus 3, and that is over x plus 2, x minus 3. Okay, so now canceling things out, right? X plus 2 and x plus 2, x minus 3, x minus 3, and all four terms will cancel out there. So 4 is to combine and simplify, right? So we're going to have 3x times by x minus 3 minus 5x plus 2 is equal to -25. 3x times x is 3x squared. 3x times -3 is -9x minus 5x. So again, I'm going to put my brackets in there. 5x, 5 times 2 is 10. So plus 10. And that equals -25. Now we can start combining like terms. There's no other squared value here, so 3x squared stays the same. Minus 9x, so -9 minus 5 gives us -14x. And then we are still working like from our first one, subtracting the second one. So we're going to have just -10, even though there's no other value to combine it with. Okay, and then that's equal to -25. Now, we're in a bit of a different situation here, right? We see that we have kind of like a quadratic function looking thing. So if you get to this point, you have a x squared value and an x value, then you want to remove the number value from this side. So basically bring it over and set the whole equation equal to 0 so that you can factor it properly. So that means we're going to add 25 and add 25 so that we have 3x squared minus 14x. -10 plus 25 gives us plus 15 equals 0. Okay, now that we have this expression, we can factor it. So we have an a value in front of the x. Let's use this swing method and multiply it by the last value. So we're going to have x squared minus 14x plus 3 times 15 is 45 equal to 0. What are two numbers that multiply to 45 and add to -14? It would be -9 and -5 are going to add to -14 and multiply to +45. So x minus 9, x minus 5 equals 0. And then we have to divide out the 3 that we multiplied through. So we're going to have 3 divided by 3. So for this one, we have negative 9 divided by 3 gives us negative 3. So x minus 3. And then in this one, we're going to have 5 because we end up with a fraction. So 5x minus, or sorry, not 5x, 3x minus 5. I'm switching my numbers around. 3x minus 5 equals 0. Okay, so now we have our factored form. So if we had to say what x would be equal to, basically what we're saying is neither of these brackets can multiply, or sorry, both of these brackets need to multiply to make 0. So that means one or both of them would have to be equal to 0. So we have two possible solutions. From the first bracket, if x was positive 3, then this whole bracket would be 0 multiplied by everything would be 0. So that's one possible solution. And then in the other bracket, we have x would be equal to 5/3, so positive 5/3. Now what we need to do when we solve, which is something I didn't mention in the previous problem because it didn't apply, although moving forward you guys should think about this in every question, is comparing the values that you've used or that you've solved for x to your non-permissible values. So we said at the beginning that x cannot equal negative 2 or 3, and here we've come up with 3 as a solution. So we call this an extraneous root, which means that it's not a viable solution even though it appears to be. So extraneous root, so basically that is not a solution, and we would just say x is equal to 5/3 is the proper solution. Okay, so extraneous roots happen when your solution is one of your NPVs. So it's an extraneous root because it's an NPV. Now the last thing we need to do is substitute and verify. I'm going to do it up here so I have lots of room. So we have 5/3, which honestly isn't the best number to work with, especially, sorry guys, might cut out there. So especially if you think about substituting that fraction into like the x squared minus x, right? So if you have a fraction value like this and you need to substitute it back into a fairly complex setup like this, what you can do is use your calculator to just like insert it as a decimal. The only thing is you want to make sure that you're being very careful to carry your decimal all the way through to ensure that your final numbers match up perfectly, which won't happen if you are rounding your numbers off as you do these calculations. So basically what I did was I did 5/3 in my calculator is 1.6 repeating. So then just plugging that in, I have 3 times by 1.6 repeating divided by 1.6 repeating plus 2 minus 5 over 1.6 repeating minus 3 is equal to negative 25 x squared, 1.6 repeating squared, minus 1.6 repeating minus 6. Okay, so then when I multiply that out, 3 times by 1 2/3 basically is 5, and it's divided by 3.6 repeating minus 5 over negative 1/3, or negative 1 1/3, equals negative 25 over negative 4.8 repeating is what we get from that whole expression. 5 divided by 3.6 repeating gives me 1.36 repeating plus 3.750, and it's kind of like an extended decimal there, equals, and then on this side we would get 5.113, you know, kind of dot 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 like an extended decimal. If we add these two together, we get 5.113, again kind of an extended decimal, and that matches what we had there. So we know that our solution is accurate. You are welcome to use fractions here as well, of course. I mean, obviously we've been working with fractions. You should know how to do the work. It's just that, you know, if you're in a test situation or something like that, or even if you're just doing homework, the purpose of this learning is not to know how to do a whole lot of things with just fractions for verification, right? So it's not like I'm not going to ding you on a test or anything like that if you choose to simplify into decimals in order just to make your calculations go through a little bit more quickly. Okay, so a little bit of new information there on this page. Remember the extraneous root, remember to check for it, and then only use the solution that is viable, that's not one of your NPVs. And that is everything for today. You guys have a couple of questions to try here on your own. Check the filled in notes for the full solution. So that you can check your work. And then there's an assignment here at the bottom, page 348, number 1 to 6. So give those questions a try. And as always, please check your answers in the textbook to make sure that you're doing them properly. And next time we will look at kind of expanding this idea of solving rational equations into working with word problems. So I will see you in that lesson.